I don't know what angle. We're live. Hello, world. My name is Alan. We're practicing LeetCode. And today we picked this special problem. So we're doing some heap problems. So those that could be solved using the heap data structure. And they are from the LeetCode 75 list. And the interesting thing is that I haven't been using the heap package from the language that so the from the language that I use here. So in Go, there is a package specifically that implements the heap, and I just need to learn to use it. And so at the same time, we want to solve this problem. So it's kind of a double challenge. And let's see which makes it even more fun. And let's see what we can do within this hour. All right, so I hope it's sharing now, and we have this problem: smallest number in infinite set. Infinite set, lovely. So you have a set which contains all positive integers. Wow, how about that? Implement the smallest infinite set class. So this initializes the smallest infinite set. Smallest infinite set object to contain all positive integers. This method initializes this object. This method, pop smallest, removes and returns the smallest integer contained in the infinite set. Okay, all right. So we'll have this object, we'll have this constructor, and we'll have this pop smallest method, returns the number, removes and returns the smallest integer contained in the infinite set. And then we have this add back, which adds a positive number back into the infinite set if it's not already in the infinite set. Okay, so the word infinite set, my reaction. The word infinite set kind of startles me because, I mean, I've been dealing with infinite things in math classes. But that was some time ago, so I don't know if we have anything like that in computers. But we'll see how we can try to implement that. Infinite set. Yeah, this emotion aside, yeah, maybe I'll need to go through this emotion though, getting startled and get over it a little bit, but little by little. But I'm trying whether I should use a blue pen or a black pen to try to visualize an infinite set. I'll need an infinite notebook to visualize an infinite set, or Or here is the deal. I mean, it depends on what we need. If we need a our methods only need to take the smallest integer, right? So that might make it a little easier. Okay, then, by the way, the num, what's the num? Okay, the num is the number that we add back, is up to 8,000. All right, and then at most 1,000 calls will be made in total. Okay, so that sounds like we could be fine with the set that's up to 8,000 here. In the range, in its range, because that's what's being expected. And yeah, we're not going to add the numbers more than that are bigger than 8,000, right? Into this, so we'll have the set, and we only going to add numbers that are this 1,000 max, yeah. And we are going to make that's the requirement, that's the constraint here. Yeah, there in total. Oh, so the pop, yeah. So if they only do the pops, there will be a 1,000 max again. And by the way, we don't include zero, so from 1 to 8,000. That's what we need to have in our set. But by the way, I mean, we could think of this outside of the heap. We could use just an array, like use an array, fill it up. Yeah, we could probably just yeah, and when we want the smallest number, we'll just take the number from the beginning of our array. Yep. And when we want to add a positive integer back into the infinite set, we'll check if it's already there or not. And oh my goodness. We don't really need, I mean, we could implement it with an array by using array of, oh my goodness. We can use an array of, yeah, like, so we can implement a set with an array by using indices as our values and as our numbers, yeah. And it will be like an array of booleans, and yeah, we'll fill it up. So we'll just initialize this, contains the integers. Yeah, so basically to solve this with this, yeah, but I mean the adding, so the popping will be just saying that that this, So this, yeah, so the set and the values will need to say that the set, oh, we need to remember which was the smallest, yeah, and just yeah, this, yeah, we'll need this smallest is going to be an integer, and so we'll say that this smallest, yeah, so this is our value we need to return. Yeah, we're gonna say that, but at the same time, we want to turn it into, basically, this is the number. Yeah, we're gonna say that this is now false, so there is no. We don't even have to do that, because if we are going to, well, when we add an integer back into the infinite set, if it's not already infinite set. Okay, so here is the trick. When we add, we'll yeah, if it's not already in the infinite set. So if it's already in the infinite set, then we don't need to do anything. Yeah, I mean, it looks like we could implement it without using the heap. Yeah, I'm pretty sure so. And then we just return this smallest, because yeah, when we'll keep track of the smallest. Yeah, so this is what will be happening. We'll have these numbers, and we'll have, yeah, this is going to be like a value that remembers, yeah, it's the smallest stars here. Then if we pop something, yeah, we, that's the thing. Okay, if we pop, but there could be, okay, what if, yeah, so the problem could be this, yeah, I see what's the problem here. So if we popped like all of these, so because these are the indices, and they will be like, if they're all empty, like this one is empty now, and this one is true, then and then we like add one here, one is added, so it's updated. The smallest is here now, and then it goes like, okay, pop this one. So it pops that, but okay, and how do we identify the smallest? Yeah, we need to do the search on all these. Yeah, we'll need to do like iterate. Yeah, and then this, and it could be like 1,000 here. Yeah, so it could be that all of these are empty, and then only this one is here is true. So we'll yeah, so and then they just add and pop and add and pop, and each operation will require doing the search for the smallest one in this array. So if it's like 1,000, yeah, it's an n square, which with the heap, yeah. So we did. I mean, implementing a set like that did help us with the soft delete. I mean, we use the soft delete, so we didn't have to. The insert operation was quick. It's quick, but this finding next smallest is linear. Okay. I would say that it's sort of fine because hash table, design, heap, priority queue, ordered list. Yeah, but I mean, yes, you can implement a priority queue with an array. Yeah, and with this number of with these constraints, yeah, n square could be fine. Yeah, because it's just 1,000,000 at max. So probably it will be within the time limits. But that's not the point here. Yeah, we are kind of implementing a hash map here. Sort of, not really hash map. No, we're like a map. Implementing a map. Yeah, if we used if instead of an array, we used a hash map, we would lose the order. Yeah, because I mean, what's the next smallest now? Yeah, it's good with the set, but finding the smallest, when we remove the smallest, we need to then know which which one is the smallest. And with the map, I mean, it's not ordered, we don't know. So adding is fine, but this removing the smallest, which is finding the smallest, yeah, that's the challenge. Okay. Now that brings us back to the heap, and min heap is what we need here. So let's do it then. Let's try and do that. So we need to import this package. And this package, cleaned it up a little bit. Yeah, so this is practice. Where should we start? Oh, well, what does the yeah, let's look at the package. So and then okay, so int heap is a min heap of ints. Type int int heap. This example inserts several ints into an int heap, checks the minimum, and removes them in order of priority. So then it has several functions. Functions fix, int, pop, push, remove. Yeah, so I'll be looking at this example and type int heap. Then we have these functions. Where do we use the heap? Okay, so we implement these methods. Then we have push. This example inserts several ints into the int heap, checks the minimum, removes them in order of priority. Okay, heap pop. That's the only place where we actually used it. Should I share this example? Should I share with you guys, my viewers, this example? So this is the example. This is the example. So the package is heap, container heap, and okay, so what's happening is we are creating a type that is a heap by its, because it has the methods. And yeah, the interface requires add as an element, push, pop, or type using the routines in the package heaps implementation to call to add and remove things from the heap, use heap push, heap pop. So it looks like in this example, let's go line by line to understand it. Okay, in the package main, these packages are imported, and okay, we're initializing type, which is an array of integers. Then, so this, we're just saying this is our type now. So also we say that this type int hip has 5 methods: length, last, swap, push, and pop. Okay. And from what I understand from the package, the interface is required for a type using, yeah, that's the interface. Interface. So when we have function sort, okay, so it looks like push and pop maybe are required. That's my feeling. And what's happening is, okay, back. So we have it. If an object has these methods, then it satisfies this interface. So we can use the methods already defined to it. So, okay, let's look at the function. Yeah, this method length returns the length of this array. Less takes to and returns if these values are less or not. Yeah, the ith and the jth. Okay. Swap. Okay, swaps them. Okay. Okay, now push takes a value. Push and pop use pointer receivers because they modify the slice's length. Okay. So yeah, in this case, the receiver was not a pointer. In this case, it is a pointer. So we want to update the slice, not a copy of it. Not just its contents. Oh, yeah. Okay, now the pointer to, oh, no, dereferencing, yeah, we get this this hip, and we are adding, so we are appending integer and oh, yeah. Okay, so this takes x of type any, of type any. So we want to push this value. Yeah, and if it's type integer interface, so that's type assertion. Yeah, goaling type assertion in the Go tour. Yeah, that's what type assertion provides access to an interface value's underlying concrete value. This statement asserts that the interface value I holds the concrete type T and assigns the underlying T value to the variable. Okay, so we are asserting that that X is integer. The interface holds the concrete type and assigns. If I does not hold, the statement will trigger a panic. Okay, so without testing, it does that. But to test whether it holds, yeah, you need to do that first. So here we just do it without testing. So we are certain it's an integer, and then we are appending it to the slice. Okay. So that just appends it. Okay. Then we have this pop method. And by the way, how do we use the push? And do we use the push here? So we implemented the push, which just essentially just takes a number. Yeah, we disregard this, that we take anything and then assert it's a number. But we take this number and just push it all on top of our array, of our slice. Yeah, because we modify the length of the slice. Now, okay, this pop one takes, so it remembers, okay, this is the old slice, n is length of old, and we create x is old, it's the pop, old, okay, the length of now old is the slice, okay, that's the slice. Yeah, length of the slice. Then we say, okay, give us the last value added onto that slice, that's x. Then we say, okay, our slice now equals that slice, but we're reslicing it, and we're taking it from the beginning till, yeah, so excluding the last value. Okay. Yeah, so basically we just, yeah, we exclude the last value and we return x. Return that. Yeah, so take that number at the end of the slice, basically, and shorten the, I don't know why we had to do it, like, why we couldn't just, well, there's probably a reason why, but anyways, that's what it does. Yeah, there are a couple of, each of these methods have, those extra features. Anyways, let's look at what happens, like, when the rubber hits the road. This example inserts several ints into an int heap, checks the minimum, and removes them in order of priority. Okay. Hip H. That's idiomatic Go. So we create a heap, an instance of a heap. And we say that this heap is the type. This the H is the pointer to a type, which essentially is int heap, yeah, that we created. And by the way, as of now, this thing can only take, yeah, if you add a value, you just push it at you append it onto the slice, and then you take it from the top of the slice. I don't see like there is no sorting. So it's not like a min heap yet. Or maybe it is already by the power of interfaces. Because, so this int heap, so the heap is this, 2, 1, 3. Then we say, then we initialize the heap. Heap init and take our H to it. That's what's going on. That's the magic. Magic starts here because this heap init is this init establishes the heap invariance required by the other routines in this package. And it is a idempotent with respect to the heap invariance and may be called whenever the heap invariance may be validated. The complexity is ON. All right. All right. So I mean, so far, I just understand you got to initialize the heap. So this initializes the heap invariance. Where is our heap? Where is our heap? Now we say, we use the method heap push then, and it takes this heap interface. So this init, by the way, it takes an interface which is something that has push and pop methods. So if it has push and pop methods, it matches our interface for this type. Yeah. Okay, so the interface has been defined. I like it. I like it. And so it's a heap, and it takes that thing. It has another field. This interface actually has another embedded field. It has the sort interface from the sort package. The sort interface is the number of elements. Type interface. So from the sort package, what does it do? Length is the number of elements. So an interface has methods, but that's a type. Oh yes, but the interface here is like a type, so it's a struct. Okay, that's a type that has methods and has an embedded field, also an embedded field that is an interface from the sort function. Oh, and what does that interface do? So it has less and it has swap. Okay, it has length as the field, and it has methods less and swap. Okay. All right. Okay, now we see this less and swap. Because it looks like for this to work, so it's embedded. So to fully implement this interface, you need all these methods then. I'm definitely not sure. I question now if that's an interview format question for using the heap implemented by Go, as it is implemented in Go, because I now see like why they implemented all this stuff. Yeah, you got to bring this stuff basically, so you can use this push and pop. Yeah, you just carry it. You got to have all this stuff. Yeah. You got to have all that stuff. Now it implements. Now we can use, we can like initiate a heap and do our things. Essentially. Okay, since we started it, let's do it then. Yeah, now I see why in this other heap init. Okay, then. So I'm starting to, I think we kind of followed so essentially, yes, you need all these methods so you can use these things. That makes sense. So we don't need the package main. Integer heap built using the heap interface. Yeah, so we are using the heap interface. Let's clean it up a little bit. Sure. So how are we going to use it here? Yeah, we create our own types. Those types will have these methods. That's quite an exercise, I have to say. Quite an exercise. Let's stand up and stretch a little bit. Yeah, so what's good about it? This is practice on several things, including interfaces. Yeah. So this heap init, it takes this age has to be a heap by the interface. So initializes, then it just pushes to this heap, this number 3. Then in this example, then this print happens, and this print takes 1, the smallest one. So it was sorted essentially. Yeah. Actually, if you look at what's happening here, yeah, it's a package sort, so it's sorting them. Length is the number of elements. Yeah, in this package sort, less. Comparisons, swaps. So it sorts them. Just to clarify, this doesn't look like an interview format solution, because remembering all this just to implement a heap, you might as well just implement it yourself. Just implement then. Yeah. So this is more of an exercise. Let's see, because in this other solution I'm looking at for another problem where they actually did all that. Yeah, took all those things. Yeah, you need all that. Then it pushes, then it prints, and then it goes over. For the length of that heap is more than 0, you do the pop, and then it just pops all of them one by one. That's what it does in this example. And then it prints 1, 2, 3, 5. Yeah, the minimum is 1, it says. So they are sorted. That's the magic. They're sorted. Let's see for the practice. for this red pencil and for the practice with interfaces, let's see if we can use that to solve this problem here, just for the practice. And we have how much time? Yeah, we're already 15 minutes into. Let's see, like 10-15 minutes. You can do that, because the other solution that initially we came up with, which is n squared, but it would be like shorter and yeah. But it's n squared. Yeah, but this one should be better. It should be like, I believe that sorting would be more effective than linear. Well, sorting is n log n. Depends. Oh gee. Okay, so what do we need? We need these types. So this type has all its methods. Okay, so now int hip the calls will be done on the smallest. So we need to say that this typed infinite set and when we call the constructor, it should create. So this constructor should return us this int hip. So I guess this is what should happen. The int hip and but the length of this int hip should be, we need to like fill it up with the numbers up to 1,000 for range. When we actually go over, for range h, we need to say that this h I by the way, we need to create pointer to a slice can we create it at a certain make length 1001? I wonder if we can do that. So now we go over it, and I'm gonna say that we're gonna fill it up with these values, which is don't need the 0 though. Oh, wait a second. No. We need only 1,000. We don't need the 0. So the first one will be 0. So we want to say +1. So that's what we're gonna fill it up with. That's with this offset. Then we called. Why is it a pointer to a hip, by the way, when we created? H is a pointer to a hip. Then we will call initialize. It takes a pointer and it doesn't it takes a pointer take hip and it takes an interface. Oh yeah, so this one specifically isn't pointer to an to this one, but this one is not a pointer. So I mean it's a receiver by the value, not by the pointer. And so this implements the push and pop. This one doesn't. Interesting. Well, let's see. Yeah, so obviously this works because that's what it is. That's how it is. But yeah, but so this hip value has these methods. And the hip value and interface. Interesting. Anyways, yeah, well, that's an interesting question, but let's so let's practice. So this creates our hip and initializes it. Now we want to have that our set if we return, that our set has the has the field age of type int hip, right? Right. And has this field age type int. So, and now we can return we want to create this type with age. So that creates our struct. Okay. All right. Now, when we call this, so this age is gonna give us that hip. When we want to pop smallest, then we just say this age, and yeah, we can use the hip pop. So this hip pop should hip pop should do that, yeah. And then it should return this hip. And this should be Yeah, by the way, when we do the heap pop, we need to do the fix. I wonder if we need to do the fix, because we might, or do, because there is a method push fix reestablishes the heap order after the element at index I has changed its value. Oh, changing the value at index I and calling fix is equivalent to plus call and remove followed by push. Okay, we might not need to. So the pop removes and returns the minimum element according to less from the heap. The complexity is okay. The pop is we go log n, where n is heap length. Pop is equivalent to remove. Moves in terms of the complexity. Okay, so it's actually log n is a good complexity. Oh, it's better than n. Much better. Much better. Okay, let's go back to this. So then maybe we just, okay, if we want to add back the value, we use heap push onto the heap, the complexity, log n. Okay, so we just need to say heap push. So this pushes, yeah, then the heap push needs heap and it needs a number, yeah, num. And that's kind of, that could be what we need. Cannot take an address of type int heap. Oh, why it couldn't? It could do it here, but it's the address of int heap. Heap is int heap. Yeah, so in so they create okay, in this example from the package, they create a pointer to this type, to this instance. Not create a pointer not take address of value of type. Line 20 when you type assertion. Use heap pop this h value of type any as int value in the return statement need type assertion. Oh, hip hop returns. Oh. Oh, hip hop returns any. Okay, so we need type assertion here. We need to say that this thing int. Yeah. Yeah, so this problem would probably go away, but the pop has pointer receiver. I wonder if we actually need. Let's. I see how this thing can become like can become spaghetti. Int heap does not implement heap interface method pop has pointer receiver. Oh yeah. Okay. Yes, that's the thing. That's why the int heap, these methods are implemented on the pointer to int heap type. Pointer receiver, not on the well, we need to dereference them. Yeah, we need to. Okay. Well, essentially. Oops. So when we do pop, we need these work on the pointer. Heap push this h num no value uses that use this value. Wow. I mean, this is a good example of how you can get like spaghetti, like just like that. Out of nowhere, you just have the spaghetti. And I think this is a good example because, yeah, it's heap push. Where is the no value? So this heap, we have a pointer to, which is we're using a pointer to, num is definitely a value. Could it be nil at this point? Well, before pushes move is used, the constructor should be run. Yeah, so the constructor this method, so the struct is initialized with this field. Now the constructor creates this int heap, fills it up with data. Oh, by the way, it should be happening only if it's not there yet. So we shouldn't push anything that's already. Yeah, we need to do that check. Oh, we don't need to return. Jeez, there is no return. Yeah, if this function doesn't return anything, if this so this is a pointer type. Okay. In this case, it's a pointer type. So now we call for its field H, which is a heap. This is the object heap. And on this object, we actually take a pointer and we call pop on it. Yeah, we call its method pop. Okay, but here we need to check if this H, yeah, but I mean, when the field is called, we don't need to put, yeah, we just call the field. If this H num, yeah, I mean, how do we know if it's already in the infinite set or not? Because, is there a method we can use? Last lane swap. Oh, we can't use an array. My goodness, we need to use a hash map. We can't use an array. Because array doesn't allow us to know if the value is there or not. But if we don't check, we'll create. I mean, we can use an array as a hash map. type is of ints. Well, it's 1 hour 15 minutes into this practice. I think we should take a break. And what I like about this specific exercise, it brings us deep into this, into the interfaces, pointers, methods, and all the good things, all the cool stuff. Yes. So I would say, yeah. Let's look at the solutions. I would say Golang solution with smallish explanation. Let's check out the solutions because so that's somebody else's solution. So when they do add back, what is this method in heap? Oh, it's int heap, I guess. It's not a method. It's oh no, it is. So wait a second. It's a field. Oh, they keep the map. Okay, so they just track in heap using a map, whether the value is inside the heap. Ooh, okay. So they added additional. So they track the smallest. I don't know if you need to do that, but okay, there is a method. Okay, the field added. That's the kind of the int heap. By pointer. And now that explains it. Okay. And the rest is probably the same. Yeah, so that's how they went about it. They create another, they used more memory to store the actual set. Oh, wow. What an interesting exercise. I wonder what could be a good solution for an interview here. Because this has like quite a few moving parts. Essentially, yeah, it has this heap that allows you to have the priority queue, efficient priority queue. Then it has this map to kind of to remember the sets. So to have the set functionality, yeah. The constructor creates an int heap. Initializes smallest infinite, and then the map. So it creates it with a map. By the way, they never filled it up with 1,000 values. So they just create a map of booleans. Weren't we? I think the initializes all positive integers. And how would that work? You got to have those numbers somewhere. Yeah, because here we say like, okay, this int heap is just a heap. It's just an array, but it's an empty array. And that's an empty map. So our constructor never gives us the values, whether the value. And that's an interesting question. In heap, well, they might not. I don't know. We'll need to check that. So two things here. Yeah, we're running out of time, but it's a couple of takeaways. This heap package, not real an interview format solution. I think that implementing priority queue with an array would be the way to go even with n square time complexity, and yeah, and squarish for this situation. Well, could be, yeah. And there is tons of valuable exercising in this problem by practicing this one. So, but yeah, would need more time to kind of grind a little bit, play a little bit with that, and maybe offline. And so, good practice. Thank you for watching, and we'll see you in the next video.